Okay, here's today's joke of the day. Why did the math teacher want to become a farmer? She was pro-tractor. Stay tuned, they get better. Hey, we want to do 1C notes today. This is in Unit 7, and this topic is called the Pythagorean theorem. I'm sure many of you have heard of it before. We're going to see how it's done just in what I call the generic triangles that are just, the numbers are just there, and then we're also going to do some applications with it. So let's get started first with some vocabulary. And the Pythagorean theorem is used to find a missing side, specifically of a right triangle. Okay, so when I'm looking at this triangle, I have two sides, A and B, and then I have another side, C. Okay, in order to use Pythagorean theorem, I have to have two of these and can find the third missing side. Okay, so if I'm missing A or B, those are called the legs. A and B are the two sides that form the right angle. Side C, which is opposite the right angle, which is the longest side, is called the hypotenuse. Pythagorean theorem says for any right triangle, a squared plus b squared is going to equal c squared. So if I take this leg and square it, and I take this leg and square it, that's going to equal, when I add those two together, that's going to equal this number squared. So sometimes I like to write it just like this, a leg squared plus leg squared equals hypotenuse squared. I do it that way just because sometimes they don't use A's and B's. Like in this case, they're already using C's. But you just have to remember the number over here on the right side, it has to be the hypotenuse, which is opposite the right angle. In the last couple lessons, we did some work with square roots. So for example, the square root of 18, we simplified that to 3 square root of 2. Square root of 15, we just left square root of 15. On today's lesson, when we start Pythagorean theorem, they're going to ask us to round each answer to nearest tenth. That involves using our calculator to find the square root of a number and use the decimal form for our answer. So if I want the square root of 15 as a decimal, I'm going to use the calculator. Usually calculators, everyone is a little bit different, but usually the one that's right above the x squared button on our class calculators, that is the square root button. In order to get that function, I have to push the second, and then I push the, whoops, wrong one, sorry. Then I push the x squared button. Okay, so second, and then this x squared button, which is where the square root is right above it. Then I punch in my number, in this case 15, and push equals. And there'll be this big long decimal where they'll just want you to round to the nearest tenth. Okay, when we're dealing with sides of the right triangle, we do it nearest tenth. So 3.87, the tenth is the 8. It's going to raise up to a 9. So 3.9 would be my decimal form of square root of 15. I do the same thing for square root of 18. So square root, this is what it should look like on your calculator. Punch in 18 equals, round to the nearest tenth, 4.2. Okay, so keeping that in mind, let's go to this one. So when I look at this right triangle, I've got a leg and the hypotenuse. I'm just going to even label the hypotenuse because I know in my formula, legs squared plus legs squared equals hypotenuse squared. Order of operations says I'm going to do the squares first. So 8 squared plus 13 squared. I'm going to add these two together. And just as we learned in the last lesson, that if I want x, not x squared, I'm going to square root both sides. So approximately, because when we get the decimal form, we are approximating it. So in my calculator, I'm going to put square root 233, and it's going to round off to 15.3. That's it. So we are saying that the hypotenuse here is about 15.3. And that would make sense because that is longer than the other two, and it needs to be. Here, again, I'm going to identify the h, the hypotenuse, and I'm going to set up my equation. 22 squared plus 27 squared is going to equal x squared. Leg squared, hypotenuse squared. I take 22 times 22 on my calculator. 27 times 27. The calculators do have a square button. In fact, that was the one that we punched before. So if I want 22 squared, I just punch in 22. And I'm going to push this x squared button. You can see it gives me my exponent here. Push equals, and there's my 484. And that is 22 times 22. Do the same thing over here. So I'm going to add those two together. I get 1,213. I want x, so I'm going to square root. This is a nice one to get the decimal form and not have to simplify it. So I'm going to square root 1213 and get 34.8. Okay, why don't you stop the video and do the next two, and then we'll go from there. Okay, so I didn't take the time to write out all those. At the end of the video, I will put down all the notes straight up, and then you can take a look at all the work for that. But here would be the two answers that you'd get for number 3 and number 4. Now, 5, 6, and 7 all deal with Pythagorean theorem. We just got to get the right numbers. So let's take a look at number 5. The right triangle is this piece right here. Not the whole thing, just this piece. Okay. They want me to find x. That happens to be a leg. This side here is equal to this side, so that's going to be 24. That's the hypotenuse. This side is 22. Because it's an isosceles triangle, that breaks this up into 11 and 11. So now I can look at just part of the triangle. That triangle right there has side that is x, the side that is 11, and hypotenuse that is 24. So when I write my equation, x squared plus 11 squared equals 24 squared. 24 is the hypotenuse. Sometimes people even like circle that just to remind themselves that that has to be over by itself. When I take the square root, or square that and square root, I'm going to get x equals 21.3. Again, we're going to write out the equation. If you don't understand how to solve that, then you'll take a look at the notes at the end of the video. This one's kind of weird because I've got this extra little chunk over here. In order to make my right triangle, to find this, I draw this auxiliary line in here, kind of an extra line that helps me solve it, and that's also x, straight across there. So if I can find this x, that's going to be the same as this one. Now this 18 goes all the way across. So that's not a side of the triangle. Okay, but this is 5. So that makes this side of the triangle 13. Now I've got my 3 sides of the triangle, the right triangle, and I have an x, a 13, and a 16. So when I set that up, the 16 is the hypotenuse. So I know that's going to be the one on the end. When you work that all out, you should get 9.3. Okay, so take it upon yourself. If you're not sure of how to solve that thing, solve it and make sure you know how to get 9.3. This one's a little bit different. They want us to find x, which is this whole side. But again, this whole side is not part of the right triangle. We've got 2 right triangles. One is this one on the right side of 12 and 29 and something. And then on the left side here, we've got 12, 14, and something. So when I put the something and the something together, that's going to give me all of x. So let's just label that A and B. So I've got this little triangle here on the left where I've got 14 as the hypotenuse. So A squared plus 12 squared equals 14 squared. When I work all that out, I'm going to get A equals 7.2. Then I'm going to look at the triangle on the right, and I'm going to go B squared plus 12 squared equals 29 squared. 29 is the hypotenuse of this right triangle. When I do that, I end up with B equals 26.4. X is going to be 7.2 plus 26.4, 33.6. All right, let's stop there, and we'll finish in the next one.